Hi, can all hear and see the slide? Okay, good. So, okay, sorry about that. I think there's some issue with my PC today. Okay, let us start the lecture quickly. So today, this section, I will introduce you the dynamic memory allocation. Switch to another PC. Okay. Okay. Yeah. Okay, so in this lecture, I will cover a few important concepts before we cover the data structure. Yeah, I will introduce you the structure definition in C programming and also show you the static data structure and dynamic data structure. And also after that, we'll cover the memory allocation, which is the very important concept before we talk about the linked list. Okay, so this part is important. So before, yeah, it's a basic component you need to know about the data structure. Okay, before that, I would like to give a quick overview about C programming you have learned in 103. So in 103, in fact, in any programming language, you should know how to the basic component you need to know. First, you definitely need to know how to read the input from the user. Yeah, in C we use the scanf, so make sure you know how to use it. Next, you can read. Of course, you need to write. You need to display some output. So printf you definitely need to know. Then in any computer programming language, you definitely, because your microprocessor only know arithmetic and logic unit, so they only know how to do all the arithmetic, plus, minus, multiplication, division, and modulus, and also the logic and or not equal, not equal, greater, lesser, greater, equal, lesser, equal. These are the basic component, basic operator. You definitely have to know all this. And then, uh, since the computer is working on running some repeated procedure, so some while loop, for loop, and if else statement, you definitely need to know. So these are the basic C programming uh, you need to know. In any programming language, I would say, yeah, you need to able to read, write, do some arithmetic, and do some control, if else statement, and while loop repeatedly do the job. So this thing we will not cover again. You're supposed to know in 103. Then of course you need to know how to create some function. Array, 1D, 2D array, the character string, all this, and how to write the recursive function. These are the things you have learned. I think in 103 we also cover the pointer. So reference and dereference, uh, how to use all this operator is important. It's very important in this uh, data structure part. And also how to pass by reference, pass by value in the function. Yeah, these are the things you need to know. So in the so-called the static data structure, it is trying to, what does it mean? Static data structure. Static means that the at the times you declare that variable, maybe integer, maybe long, maybe float, maybe double, maybe it's 1D array or 2D array. At the compound times, you already allocate fixed memory for it. And that kind of a variable is considered as a static data structure. Then very soon you will find that this may not enough. A lot of time you face a problem is like you would like to let the user decide your array. Yeah, maybe 1D, maybe 2D. For example, the name, the length may be different. Different person, the number of character in your name may be different. So you would like to create different length. But using the static data structure, you can't do so because you cannot let the user decide the size of the array. You have to decide it at the compound time. So in that situation, I think in 1003, a lot of time, what we did is we just simply create a very, very large array to ensure that there's no out of bound problem. Yeah. So can we have a better solution? In that, probably we have to introduce this dynamic data structure. We have to use this. The dynamic data structure later we will show you how to use it. It will let you to decide the memory allocation during the execution time. Yeah, instead of at the compound time, you have to fix the memory. Dynamic data structure is why you call dynamic, because it gives you this kind of a flexibility. Is you can dynamically decide the memory allocation during the execution time. Yeah. So to do that, and that is one problem. Another problem, you find that maybe that in 103 they have covered. When you declare an array, you will find that you only can have all the character, the same type, 64 element. All these 64 element must be character. And 2D array, 8 by 8, must be integer. But in your real world, in your daily life, your problem sometimes the data you have is not just integer. You maybe, for example, the student information, including your age, your name, maybe your home address, and so on and so forth. And this information, some can be integer, some can be string, some can be floating number. So one way is you create multiple variable. Another way, you can use the derived data type, or C structure. So I can define a new data type by this struct keyword. I can define this struct nodes, and then I can include two members in this new data type. One is integer to store the age. Another one is the floating type to storing your height or anything you want. So I can combine a collection of data into one new data type defined by my own. Yeah. So this I'm not too sure. You should learn in 103. Yeah, it give you it make your variable easy to manage, because one variable contain several different data type, and you can store different information in different member. Yeah. So, but all these thing is considered a static data structure. Yeah, you also can do this way. Maybe before I move this, maybe I can give you some. Yes. To learn all this, is the how to define a data type is something like this. But how to do that? the easiest way, don't know whether you can see. Yeah, okay. So the easiest way to learn is just simply create a new project. Yeah, this is the code block. I just simply create a new one. To learn this, maybe I just create a new project. Yeah, hello world. Okay, to learn it. Okay, before at the beginning, you can just click run. Okay, where is my? Okay, it's here. Okay, initially I create a simple project. Maybe put bigger. I hope you can see. Okay. So to declare a new structure, let's set for nodes. Inside I can have the student age. I define. I also can have the floating number, maybe your height. Okay, that's how to define. Then I can use it. So static data structure, that means everything is defined at the compound time. So to use, maybe call S1. So S1, I can include the age for 15 years old. Maybe S1, the height is equal to 1.71 maybe. So you want to print it up. I think all this is what you have learned in 103. So not surprising, I just simply compile, hopefully no error. And they will give me this. It's 15 and 1.71. Okay, so that is how to define. Of course, you can try to do something else. I can also, yeah, you will verify, okay, I can try to create a pointer S1 PTR S1 PTR equal to address of S1. Then PTR. In that case, it's a pointer. I have to use the arrow operator. Is there any error? No error. I will get the same thing. That's how to use the structure definition to define a new type. But very soon you will find that there's a problem. You find every time I need to declare, I need to type two words, too troublesome. So there's another one called type define. I can simplify my definition to maybe call std student, I don't know. You can give whatever name you like. If you do so, then I can simplify this to std equivalent. I can do this. After I define, I simplify the name. I try. Again, it's still working. So that is how to define, how to use the type define to give a new name of the data type. There's a lot of things you can do. You also can student, I think I also can do this way. I can create a global variable for student. Yeah, this after the C definition, you immediately follow by the student. Yeah, then this is the variable. The student is the variable. That means it's a global variable because I put outside the main function. So can be 17. You can see 17 is here. The student age I define. This is the variable. Yeah, there are some details you have to take notes if I do the other way around. If I do, I also can type define this way. Well, in this case, actually is trying to give a new name. Fruit is the type. It's a data type. F1. F1. Apple. F1. Orange is 5.1. Okay. So that is a few possible way to define a new data type. Okay, so, but all this is still the static data structure. I can include a few things you need to know. I can include the array in the as a member. I can include pointer as a member. Yeah, but one thing you have to take notes is this one. Yeah, if you do this way, you will get the error. In fact, to learn all these things, you don't need anyone help you. You just need this IDE. You trying to build it, they will give you the error. If you give the same member, two members have the same name, even though they are different type, you will get the error. There's an error. They will tell you there's a duplicate member. You must use different name. Then there's no error. Okay. So that is how to define the derived data type. But next, you can create a new data type, but it's not enough. I need to have a more flexibility. I want to decide the sites, the memory sites during the execution time. So by doing this, I need the dynamic data structure. The difference between static data structure and dynamic data structure is static data structure, they store all the variable in order. And dynamic data structure, they will allocate using the heap memory to store. So the memory allocation may not in sequence. Sometimes maybe different computer system, they may store the same data in different places. Yeah. Those static data structure, because they know the memory size at the compile time. So at the compile times, the compiler can decide know the memory size, so they can put everything in sequence properly. So a lot of time you may face a problem is like when you're trying to access the array, if you're out of the range, you will find that the number you got actually is another variable, the value of another variable, because all the variable they are stored in sequence, in order. So if you're trying to access the out of the range index of the array, you may trying to access the next variable in the memory. Yeah, for the static data structure. For dynamic data structure, you may not have that case. You will find that when you access something out of the range, actually it's just some random number. It can be some random number. Sometimes you are lucky, you maybe get the next variable. Yeah, but it may not be always correct. So in short, you will find that normally we have 3 scenarios. In 103, normally is the first case. You know the data size at the compile times. At the compile times, you already know all the data size. And then the next one is what I mentioned just now. You want to let the user decide the data size. Yeah, that one you need to use a dynamic data structure. Then the last one we will discuss on next Monday, which is using the linked list. It's not enough. You know the size is not enough, because I even want to insert and remove certain data. So array, you can't do it, because you want to remove one data. Even it's a dynamic data structure, it's still not enough, because I want to remove certain data in the middle. Is very difficult. Yeah. So how to remove and insert the data during the execution times? Yeah, that will cover on next Monday. Today we will just cover the second scenario. If I want to create an array, but I want to let the user decide that array size. What should I do? So you need to use a dynamic allocation. How to do this dynamic allocation? Yeah, actually there are 2 functions you need to learn, and you will see these 2 functions in the next few weeks. When we cover the linked list, when we cover the tree, all this, whenever you use a dynamic data structure, for the linked list, for the stack, for the queue, for the tree, you need to use this malloc function and free function. Malloc function, in short, is trying to do the dynamic memory allocation to you according the given size, the memory size you want. And you will return a void pointer to the allocated memory. And then free function is do the reverse way. It's trying to free the memory, trying to deallocate the memory. Yeah. And take notes, the return the pointer is not null, it just free that memory allocation. Okay, how he work again, the easiest way. And these 2 function is in this stdlib.h. Okay. So to do this, I have to include this library. That's the first step. Then maybe to simplify my code, I don't need this. I just keep this one. Maybe I want to create an array of student. This one I don't want. Maybe to simplify my example, I trying to have a make it clearer. This one, this way. Okay, I create an array. I using the malloc. So okay, I think this one good. This one, this time I use the malloc. So st, because it returned the void pointer, so I need to cast it to the same data type first. Then I use the malloc. Then I need to know, I trying to create an array with 5 members, with five element of this student type. Maybe I need to know the size of student type. Then maybe I have 5 elements. I trying to for I equal to 0, I less than 5, I plus plus. Then I trying to assign S1 PTR 1 H equal to I S1 no TPR I equal to I times 7.2 maybe. Then after that, I just simply print it out. Maybe I can print out all of them. One is data. This one is I. This one I also put I. Does it work? S1 is the pointer, so this one is the array. So okay, should be dot. Yes, I should use the dot. Okay, then I got this. Yeah, that is using the dynamic allocation, which means actually I can change. I can let the user, maybe I can let the user, I can use a scan, I can declare a new variable for integer number. Then I can use a scanf. Maybe I let the user decide the array size. In that case, I can change it to number. I can do this. Oh, sorry, semi-comma here. Okay, I let the user decide. Let's say I put 7. Okay, what happened? Yeah. Oh, forgot. Yeah, hold on. This one I change. Everything need to change. Here need to change. Here also need to change. Okay, one more times. I trying to let the user decide the size. 7. Yes, then now I have 7. So now become very flexible. I can change a type. This one is times. No, it's the pointer. Then what is the difference between? The difference between this one, yeah, I can decide. First, I can decide the array. The array is flexible. I can let the user decide. And then what is the difference? That's pointer. So the malloc will do this memory allocation during the execution times. So since the user provides 7, so they will allocate the 7 times the size of the student type. This student type need how much memory? There's an integer and floating number. So properly is an 4 byte, maybe 8 byte data per data. Then you have 7. So they need to reserve 28 byte data maybe. Yeah, they will do the calculation for you. You don't have to. You just use a side of. They will do the calculation for you. Then multiply the number of data. Then they will allocate this amount of memory for you to store all this data later. And tomorrow another user maybe change their mind. They will input 10, then they will allocate 10. So this is the good thing of having this kind of dynamic data structure. Is flexible. You can let the user decide, increase to decide the memory. Static data you cannot. At the compound times, you already when you declare the array, you already need to decide the size of the array. So if it is changing the pointer type to student, yes, I need to use the pointer because the malloc return a pointer. And specifically it is typecasting the student type onto the, yes, I'm trying to cast. It's a good practice because you know that this malloc return the void pointer. So, and my left hand side here is the student type pointer. So I'm trying to make sure that this one give me the same type. In fact, if you don't give it, it's still working. But I think it's a good practice. I'm trying to do so. Yes. Yeah, if you use the normal way, you can't let the user decide the array size. Okay, so that is the dynamic data allocation. You can draw and play around with it. Yeah, there are some other small issue. When you play, you have to take notes. Yeah. Of course, this one I forgot to do one thing. After you finish everything, remember to free it. You no longer need this variable. For dynamic data structure, you need to free. Of course, here no issue because I only write a very simple program. You won't run out of memory. So it is still alright. But good programming practice. Yeah. It's trying to free it. This time I also can put 10. Yeah, then they will generate 10. It's very flexible. I can let the user decide the array size. Easy. Okay, so malloc is used to dynamically define a size of the structure so that we can change the size whenever we want. Yes, that is what the purpose. Yeah, so that's what we want. You want to let the user decide the data size, then you can use the dynamic data allocation. If at the compile times you already know the size, then you will just use the normal static data allocation. In short, you just create an array. It's good enough. But when you use the malloc and the free to dynamic memory allocation, for that particular variable, is because you don't know. At the compile time, you have no idea how big the data it is. If you're not doing this, you will find that it's still working in this circumsystem. But when you create when things get more and more complicated, you will find that if you don't free it, you may run out of memory. Okay, maybe I hope I still have some time. In fact, you want to learn this thing. Another thing's important is to observe this one. I want to know what happened here. I want to know what happened here. Another important tool in the code block or any compiler is the debugger. I can use the debugger. See whether I can show you something. Okay, that is the debugger. So now I provide maybe 10. Okay. So now I stop here. I'm trying to create. So at the beginning, this one is just some random number. I use the next step. I move next line. You will find that this one is 781BD. So you can go and see 781BD0. Okay, now there's nothing here. They already allocate this memory location for storing the data. So now I'm at the line 17. You can see 0 is insert. Next one. Yeah, again 0. Then this one supposed to be my I is equal to 1. 1 times 5. They will assign 5 to here. Where's my... sorry, 5 is here. This one will store this floating number. Yeah, floating number will be here. Then you can carry on. So now I equal to 2. 2 times 5, you get 10. Will be stored here. So here will be updated. You get in hexadecimal A, which is 10. Yeah. So actually, this is how they start storing the data every iteration. You can see they start updating every iteration. Let me all the way to the last line. Okay. So the data, the 10 data will be stored in this location, this memory location, allocated by the malloc. And when you free, what happened? Actually, you free. You actually just free. Yeah, all this data will be free. They will free this memory location to you. So another maybe after that, if you're trying to do any memory allocation, they can reuse this portion because this portion is already free. But take note that the S1 pointer, after you free, the S1 pointer still point to the same place. Just this memory location is free to use now. Yeah, no longer in use. But the pointer still remain there, still point to the same place. So that is the common problem. Different computer, how they actually free this memory location. Some computer may not really free it. They just simply let this location can be override by another variable later. And so that's why you have a problem. Is like sometimes if you didn't free it, you find that, or you free it, you make some mistake here and there. It may work in your PC, but it doesn't work in the platform we are using in the Hacker Earth, because the way they free are not exactly the same in different systems. So these are something you may need to take notes. Yeah, when you free this memory location, you're not supposed to go and try to access it again. Yeah. Although you still have the pointer, your pointer still store the memory location of this memory block. You still can come back to the same memory block. And sometimes the computer may not clear all the memory here, but you're not supposed to reuse them. Otherwise, you may face the problem like in certain system is working, but your algorithm, your program doesn't work in another system. Okay, so that is so getting the user the best practice to use. Yes, will you reference data after using the free? Yes. Normally, you still have the pointer. Like I said, the pointer is still there to point you to this location. But the content should consider as all are the rubbish. You should not trying to use them. again because you already free them. So when you free the location, does the value store for the structure get deleted? You can see here they actually delete it, but not guarantee because I see some system they may not clear the memory. They just free that memory location for other purpose. You can let other use other variable to override it. Sometimes they just to save their power, they don't free the memory. They don't really delete or clear the memory. They just simply free that memory location only. So the data may remain there. Sometimes in some system, I have to say in some system. In this system, in my computer, you can see that they already clear. They do some clearing. But they also not assign 0. They assign some random, I don't know what it is. Yeah. Again, I think why, because this one, the return value is the void pointer. Okay, let me close my program first. Okay, so take note that malloc, they actually return a void pointer. So you better cast it to the corresponding data type pointer before you use it. That will be a good practice. You don't do that, I think normally it's still working. But I think it's a good practice to ensure you cast it to the right pointer. Okay. Other there in this STD library, there are another tool called call block and relock. Okay, for malloc, take notes, they only allocate the memory. They didn't, if you notice just now the example, if you maybe you can go back, later you watch a video, you can go back to watch, you will find that actually they only allocate, malloc only allocate the memory. But the content in the memory will remain there. They didn't clear for you. If you want to clear, you have two ways. One is just simply write a loop to make all the element in that memory location as 0. Or you use another function called call block. Call block is they will do the memory clear for you to initialize all the element as 0. Yeah, you can try to use this. And yeah, whether you use which one, in the end, remember to use the free function to deallocate the memory when you no longer need to use it. Yeah, reallot is like after you create the malloc, you create, maybe I create a 5-element array. I change my mind. I want to reallocate a bigger data, more data. Then you can use the relock to increase or decrease the allocated memory. If you enlarge the allocated memory, the original data will remain there. They just increase extend your memory block, allocate more memory for you. If you reduce the size, then they only keep the data up to that. Let's say you create 5 elements, you use the reload to reduce to 3. They only keep the first 3. The last 2 will be removed. So that is the reallot. But in this module, normally we only use the malloc and free. I think that is good enough. What is only void? That means there's no it didn't represent any data type. It just a void pointer is like is a special data type. They not represent they are not integer, they are not long, they are not anything. They're just a pointer, simple pointer. So you can cast this void pointer to any data type you want. void is a special data type. I would say it's a special data type. Yes. So call log will assign all to 0. Okay. So okay, I think this is just declare a malloc. I already show you. So today you have learned about this malloc and free. I suggest you go back and try to create some simple function and then play around with this malloc and free. Yeah, there's a lot of small issue like the return value is a void pointer, whether you can cast it or not. And yeah, if you create a new data and also trying to use a structure definition to declare a new data type, make sure you familiar all the syntax. So call block, yes and no. Call block or malloc, which one is better? A lot of time actually you don't really need to do this kind initialization because very soon you will assign the value to it. You just need to take note that if you didn't do any initialization, the content in the memory is just some random number. And different system will give you different number. And that will end up, sometimes you will find that it work in your system, but it doesn't work in another person PC. You use the same program. It's just simply because you didn't initialize your dynamic data structure properly. Okay. So after you're able to create the malloc, you know how to define the structure. Okay, on Monday I will cover more details about this linked list. Before that, before I end today's lecture, I just want to highlight, you define this data structure. Actually, I can put any member here, can be character, can be integer, can be array, can be pointer. There's one important element you need to know. There's a cell referential structure, which I can also include the same type of a pointer, structure nodes pointer, in this structure defined data type. Yeah. So this is a very important element before we cover the linked list on Monday. Yeah, I will cover this thing again on Monday. Yeah, so today you... Okay. Wait. Okay. So today you have learned how to use the structure definition to define a new type. And also you have learned about the malloc and free. And the malloc, the input argument, they take only one input argument, which is the size you want to do the memory allocation, the site of the memory allocation. And then the return is the void pointer. So I will use the casting to cast it to the corresponding data type pointer. And yeah, on Monday I will cover more about this cell referential structure definition. In short, actually they just include one more pointer, which has the same type as what you define here, as a so-called, we call it as a link, to link to the next nodes. Yeah, that I will show you on Monday again. So that using the arrow operator and dot operator, the difference is when you are declare a variable, when you declare as a variable, you use the dot operator to access the member. If you declare a pointer, you want to access the member, then you will use the arrow operator. He's referencing the pointer to the structure. Because I declare it as a, I think you're talking about the example I showed earlier. Am I? Yeah, this one. Because this thing is a pointer, I also can consider it as an array. Oh, sorry, yeah, it's a Tuesday, the lecture. So the link list. So in next Tuesday, 12:30 to 1:30, I will cover about the linked list, the self-referential structure and the linked list. How to declare a linked list and how to use the linked list in the next lecture. But today, what you need to learn is how to declare a new data type by this structure definition. Yeah, how to rename the data type and how to use the malloc to dynamic allocate some memory and let the user decide the size and of the memory you want to allocate during the execution times, and how to free deallocate the memory. And yeah, take notes here, there's a semicolon. Yeah, then you use a side off to determine the size of this data type and just multiply the number you want to create. Yeah. So this is you can consider this is a pointer, but it point to a set of memory, right? So this set of memory, I can make it as a array. I think when you learn the array, it's the same thing as what you learn in 103. When you use the array, you can represent it as a pointer also. Because this thing and this pointer actually contain S1PTR actually is contain the memory address of S1PTR0. Right? I hope you still remember. Okay. What happens if free is done more than once? You will get the error again. All these things you go back and try, you will know what happened. You will get a runtime error. Yeah, that's why a lot of things you better go and try it out rather than you ask me or ask someone. You try, you will know whether it work or not work. I think I just disclose. Just run. What happened? If you run the free 2 times. Okay, they still let you go. I think you just free again. But some system may give you error. Because you already free this memory location. You're trying to free it again. But here, I think it's still working. Yeah, I think it still can work. But normally we won't do that. May I know in this case is a pointer constant or variable? In which case is a pointer? In this case is a pointer constant or variable? This is a variable. It's a pointer. It's not a constant. You every time you run this program, the memory allocation may not be the same. Practice question. You just simply write the program by your own. That is the so-called the practice question you need to practice. To learn this, there's no any shortcut. You just simply try to declare your own whatever data type you like, and then try to play around with it. And the key, I think you learn the programming, I think it's not a lot of time people have taught is that other module you go and practice. The thing is like actually you want to really learn it. The best way is simply write a program, play around with it, and you can use the debugger to assist you to observe the changes, to truly understand how the computer update the variable inside the memory. Then you can understand how the whole thing works. That is what you're supposed to do. Yeah, before the next lesson. don't we need to check if there is memory allocate or not by comparing the pointer to the now before input? You will find that actually when I allocate the memory, again, that's why I think it's good to use the debugger. You can better understand how the thing actually works. You can see I give some input, then enter. Now I'm here. I haven't execute this line. That's it. I haven't do the memory allocation. At this moment, my S1 PTR is this memory address. It's just some random number. After I execute it, they give me this every time different C61BD0. It's this memory. It's not a null pointer. But inside the content, it's just a rubbish. I haven't give any input to this memory location. But S1 PTR is not a null pointer. So what you said, that you comparing the pointer whether it's null pointer may not work here. So what if you try this instead? Yeah, you get the error lor. You try this. Again, actually you don't need ask me to try. You yourself should go and try it out. Yeah. Okay, let me try this thing. What happened? You build, then they will tell you it's not, there's a syntax error. Yeah, we won't use the RPass in this course. When you code this, do you feel like you are being called to code? I don't get it. For me, I learn all this coding. Normally, I just trying to, when I'm not familiar about this structure definition, when I don't know what is the malloc, what is the free, I will just try to write a simple program and play around with it, so that I can, through this IDE can have a debugger, so I can let me observe what actually the computer, update the malloc, how the memory change in every single line. That can let me truly understand that particular function, how does it work. Okay? Yeah, I suggest you this weekend you can go and try to create some simple program and then play around with it to understand what is the malloc first. And then next Tuesday I will cover the linked list. How to use the malloc to declare a linked list and how to insert and remove the nodes from the linked list in the next lecture. If you have any question, you can just drop me the email to clarify your doubt. Okay? If no further question, that is today's lecture. Okay, goodbye.